Okay, our lecture is going to start with the first lecture on linear algebra. We talked about what equations form linear equations and which ones are non-linear equations. Let's just briefly mention a few words about that. Essentially, an equation is a linear equation if it is just made out of addition or subtractions of variables and constants. Okay, linear equation is made out of addition or subtraction of variables and constants. So if I have like equation like x plus y is equal to 5, that's a linear equation because I had these variables x and y, I just added them. On the other side I just have a 5, so that's fair game. So if I add x plus y plus again another x is equal to 7 minus y plus then again another x, that's a linear equation because it's just made out of taking x's and y's, adding and subtracting them, and two sides of equation are of the same style. Of course, you don't leave it like this, you clean it up some. So if this could be written as say 2x plus y, and the other side is 7 minus y plus x. We have basic rules of algebra still applicable. You can subtract an x from both sides, so this is going to, by now it's going to look like x plus y is equal to 7 minus y. You can take the y to the other side or add the y to both sides, so it looks like x plus 2y equal to 7. So I took this equation, modified it some until it looked like this one. So we realized that if my variables were just x and y, and linear equation in x and y is going to look like some multiple of x caused by having so many x's added up, and some multiple of y, again having several y's added up, is equal to some constant. So this is a linear equation in two variables. The variable now called x and y, that is customary that we use the letters of alphabet at the end of alphabet for our variables, and our constants or parameters, we utilize letters from the beginning of alphabet, A, B, C, D, and so on. Typically they indicate something that is known to us. The letters in the middle of alphabet, they have a kind of a in-between situation. Sometimes we gravitate toward one philosophy and sometimes toward the other one, but we are going to get to that. So that's a linear equation. Of course, you could have many variables, so I can have an equation looking like 2x plus 3y minus 8z is equal to 11. So that would be a linear equation in three variables. We said that we typically utilize linear equations and linear algebra in situations where there are many variables. There could be thousands of them or millions of them. They indicate things that are doing independent activities. For example, if I was considering the molecules in this air in this room, each of them is doing its own thing. Each of them is a variable. Or if you wish to think about it, the speed of each of them is a variable by itself. You cannot call the molecules in this room x, y, z. It's not practical. So you index them. How do you index them? Same equation that I had here. I can index, use indexed variables like this: 2x1 plus 3x2 minus 8x3 equal to 11. So 1, 2, 3 that shows up here is we are just ordering our variables, calling them item number 1, item number 2, or item number 3, and so on. And of course, if I have many of them, my equation might be written like this. So I can have so many of variable number 1, and then perhaps so many of variable number 2, and then I might keep doing the addition or subtraction of these variables, and I might go to a variable, say item number 1000. Okay, and the right hand side I could have just some number or something. Of course, in front of each of these variables there could be a number. That number plays the role of a coefficient. So I could have a, say, 5 here and a 7 here and say 9 here and so on. This dot 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 of course represents things that we didn't bother to write because it would be impractical to list all of them on a page. Sometimes the last index is also left as a parameter, like these parameters here. So I could have an equation looking like starting with x1, another one x2, and then going on. So indicating that we have more things to write if we actually cared about writing them. And the last one of these things might be written as x sub n. And the right hand side could be some stuff too. So in this case, n represents the index of the very last variable we might be interested in. So like in this class we have something like close to 40 students. If x were the grades that you got on the first test, this would be x1 plus x2 all the way to x40. If I expect that the number of students in the class might change, tomorrow some student might show up or some student might drop and so on, this n could change. So if I want to write a computer program, I will indicate n as a current number of students who could fluctuate. And then if I want to calculate something like an average or something like that, my formula is going to read like start from very first student to the very last student who's still in the course, add them up, and then do whatever you want to do with that data. So this is going to be a case of an equation with indexed variables where the number of variables itself is kept as a parameter. It could change from case to case. Now typically your equations comes with constants. In this case our constants better be indexed and be written in that style as well. So I might have constant number 1 times variable number 1, constant number 2 times variable number 2, and so on. We go all the way to the last one of these things I might have, whatever that constant might be, times the last grade or the last data, and the right hand side I might have some number. So these are the variety of situations where the linear equations might show up. Next, what we want to go ahead and do is talk about solution. What do we mean by solving a linear equation? Okay, solving linear equations. Let's start with the simplest. Okay, this would be the simplest linear equation you could come across. 2x equal to 3. You saw that back in the middle school. So you divide both sides by the coefficient of the left-hand side, and then you're all set. X is equal to 3/2. To be able to do this division, of course, this coefficient should be some number other than 0. So if you have an equation like ax equal to b, when you write x is equal to b divided by a, you make a kind of a fine print on the right hand side that this operation makes sense so long as you did not divide by 0. So that would be a very simple case. Let's go ahead and write an equation in 2 variables, see what happens there. Suppose I have equation like 3x minus 5y is equal to 1. Okay. So second equation, considering 3x minus 5y equal to 1. Question is, give me sum of the solution. So what do you mean by a solution? Solution means a bunch of numbers that if you plug it back into the equation, it turns it into a true statement. That is, it actually makes the left-hand side be equal to the right-hand side. Okay, we have just one equation. We have 2 unknowns in it. It's a little bit unsettling. One equation, we try to get 2 things out of it. But just give me any solution that comes to your mind. What would be a possible solution you might consider? For example, For example, what? Y is equal to anything? 1 and x 2. Yeah. By trial and error, you can come across some numbers. In this case, if y is 1 and x is 2, we have a solution, because 3 times 2 is 6 minus 5 times 1, which is 5. That is indeed 1. 3 times 2 minus 5 times 1 is indeed 1. So at this stage, this is a kind of a question mark. That is, you're trying to find out x and y that fit the description. At this stage, you have some guesses that we verify to be actually a solution. Now, suppose I ask you, is there any other possibility, any other kind of x and y fit the bill here? What kind of a suggestion would you have? Y equal to minus 1, you want to try? Okay, x would be what? So in this case, again, we try 3 times minus 2 minus 5 times minus 1. Is that correct? Is that 1? That didn't work. Is that right? So here we made a guess. Y equal to minus 1, x equal to minus 2. This became minus 6. Minus 5 times minus 1 is plus 5. That is not 1. So that is not a solution. So this is a solution. Our guess succeeded. This one not a solution. Well, try again. Try some other y's. Want to try what? 7? Okay, 7. And what do you get for x in that case? So 12. Let's try that. 3 times 12 minus 5 times 7 is equal to 1. Is that right? Well, yeah, that is a solution. Now, you had a little bit of difficulty here because you are trying to find nice numbers. You are actually jumping to another course called number theory, where people love to deal with whole numbers. And coming out of high school, you like those numbers too, but we are not going to be partial. Any number is a good number for us. We do try to stay to easy numbers, whole numbers and such, so that we don't get sidetracked with lots of detail. But there wouldn't be anything wrong if you had tried, say, y equal to 2. If y is equal to 2, what would x be? Well, instead of guessing, let's just do substitutions. We say 3x minus 5 times 2. I want it to be 1, so 3x is equal to 1, and then I add the 10 to both sides, which is 11, and as you mentioned, x is going to be 11/3. So it is fair to consider this as a solution as well. So even though these cases 1, 2, and 7, 12, and so on deserve special attention, for our course by itself, they don't stand out in any particular way, unless you go to the number theory class, and they insist every number to be a whole number. So what do we learn from this? We learn that you can choose y as an arbitrary number and get x as a result. Or you can turn the table around and choose x as you want, and then figure out y out of that. So I could have started by saying I want x to be, choose some other number, say x is equal to 5. If x is equal to 5, what would y be? So say 3 times 5 minus 5 times 1, y is supposed to be 11, excuse me, it's supposed to be 1. So 15 minus 5y, I expected it to be 1. What does that tell me? Minus 5y has to be equal to minus 14. So y turns out to be what number? 14/5, and so on. So in this case, this is another solution. So this time we started with x and got the y out of that. Now we see that there are just so many of these things, and it's impractical to try to list them. It's a typical situation in linear algebra. If there are many solutions, That means there are going to be infinitely many solutions. Infinitely many solutions, you cannot really list it. So what do you do instead? Okay, let's choose one of these variables as a parameter. That is, we fix it to be some given number. Then calculate the other one in terms of this. So let's start again. Our equation was, let's see, 3x minus 5y I can choose to say fix y. You choose y. And then say, okay, now 3x is equal to 1 plus 5y. And so x is 1 plus 5y divided by 3. No, I want to announce my solution. I want to announce my solution as the first variable, then a second variable, and if I had third variable, I make a list of that as well. So I put my solution in a parentheses. Y, well, we chose y to be whatever it is, y. Let it be y. Then x turned out to be 1 plus 5y third. That is a solution. All that you have to do is to choose a y, and then you are set. Like any of these things, if I choose y equal to 2, if y is equal to 2, this turns out to be 11 third. If I choose y to be 1, this becomes 2. So now to make it official, we say you want the solution set. Solution set is all such things where y is an arbitrary number. So I enclosed it in these curly brackets to indicate we have a set of solutions. Each solution is made out of two numbers. Those numbers, I listed them as a so-called ordered pair. Item number 1, which is the variable x, this is the x, this is the y. So we choose some sort of an order and stick to it throughout the problem. Choose some of the variables as fixed quantities and calculate the other ones in terms of the fixed ones. Put them in a curly bracket. That makes it a set, and we call that the solution set. So our solution set turned out to be the following: 1 plus 5y third and y. Now you could object, say, why did you choose y to be fixed? Why not x? I say, fair game, fair question. We can do it the other way. We can choose to fix x as your parameter. Then take this equation and solve it the other way. That is 3x minus 5y equal to 1. So you can write it as minus 5y is equal to 1 minus 3x. So y is equal to 1 minus 3x over minus 5. Or if you want to clean it up a little bit, that would be just as fine. Then you can say your solution set is set of all pairs where the first one you chose it arbitrarily and the second one is coming out of this formula. Now again, if you go ahead and choose some numbers for x, for example, if you put x equal to 2, this turns out to be 1. If this is 2, this becomes 1. Who is that? That is the one of the first guesses you made here. So we see that you have a choice as to which one of these to be taken as your primary parameter and which one are going to follow suit and become dependent. When you solve problems from 7 through 12, when it's asking you solve it in at least two different ways, that's what it means. Problem 7 through 12. What the book means by choose it two different ways, solve it in one of two different ways, it means pick one of the variables as fixed and then figure out the other one. Let me just do one of those problems just in case you want to try. Say problem 9. It says 7x plus 14y minus 3z is equal to minus 7. Here's one equation with how many variables? 3. Well, how many of them can you choose, you think, freely, and get the other ones? You can calculate only one unknown from an equation, so you have to choose how many of them? You have to choose 2 of them. Like you have to give a number to y, give a number to z, and get an x out of it. So you can choose to focus on x, and then take y and z as randomly chosen, and then calculate x like that. So how do you do this? So say 7x is equal to minus 14y plus 3z minus 7. So in this scenario, y and z are kind of chosen by us to be some numbers. Pick some number, whatever you like. Then you get your x. Your x becomes minus 14y plus 3z minus 7 divided by 7. You can clean it up a tiny bit, not that much. Minus 2y plus 3/7 of z minus 1. Now if I want to write the solution set here, what do I do? Solution set of this okay, how many elements are in each solution? 3 elements. There is an x and a y and a z. Who did we choose? We chose z to be z, we chose y to be y, and x is whatever this guy is, minus 2y plus 3/7 of z minus 1. So you can call this style 1. But what else can I do? I could say focus on y. So they try to catch y while letting x and z be whatever you want them to be. So let's write that equation like this. Now it becomes 14y is equal to, everybody else now goes to the right, minus 7x plus 3z minus 7. So y turns out to be, I divide by 14, minus 7/14 of x, 3/14 of z, minus 7/14. So solution set now is going to look like that. What's the very first element of this solution set? Is x. X is just x. Who's y? Y is this guy, which we can clean up a little bit. 7/14, 3/14, minus 1/2. How about z? Z is just z. Okay? And there is still a third style, which I let you to do. In that case, solution set, which one of the variables are turned into parameters. X and y are turned into parameters, and then you figure out what this one is going to be. So that's part of your homework. So if you have one equation and several variables, each of them can take role of a lead, and the rest of them can go to the other side of the equation. They turn out to be parameters or arbitrary values, and then you solve it in that style. So our concept of a solution is a little bit more sophisticated than what you have seen in algebra classes or in calculus classes. Solution sets could be much bigger than what you're used to. Okay, that is for the beginning of linear algebra. If you have one equation, that's what you do. Now let me just mention there is a tiny bit of difference between my style of writing solutions and what the book does. what the book does in this case is okay, let me come back here. When you choose to fix a variable or treat it as your parameter, the book goes ahead and gives it a new name. Okay, calls it S or T or U or something like that. In my view, that creates an alphabet soup of too many loose letters floating around for no good reason. So let me just mention here before we pass that in the text, when you want to choose a certain variable to be treated as a parameter, the book says, okay, I'm going to call y to be t, or I'm going to call it s or something. And when it comes to write down the solution, then it insists on using those letters. So it's going to write t here, and it's going to be 1 plus 5 t over 3. But I don't see any reason to do that. Why rename a person? Like you have just met somebody, he says, my name is Nick, and you say, I'm going to call you John. So okay, why do you want to do that? It's later on, when we are solving big systems, having too many letters floating around us is not going to be that comfortable. So that's a reason I'm just deviating from the style in the text. Next issue that we are going to talk about is the issue of systems of linear equations. Any question before we go to the next issue? Everybody comfortable with the first round? Okay, systems of linear equation. Linear algebra is used to model real life. Like you have things going on where there are many components, like the tiles on the ceiling of this room. There are connections between each tile and the neighboring tiles. Each set of connections turns into one equation. Each connection that you have turns into one equation. Then you have so many tiles, and each of them has relationship to its neighbors. So you will have as many equations as you have tiles here. So when you have a bunch of equations to consider, we call it a system. So system means simply lots of linear equations. So systems of linear equation refers to this. Sometimes we abbreviate this expression to call it linear systems. So that is simply a collection of linear equations, all of them talking about the same set of variables. So they are talking about the same situation. Such as what? Well, this is something that you come across, I guess, very first algebra course you take, algebra 1 or something, you come across this kind of equations. 2x plus y equal to 8. Say x minus y is equal to minus 2. Back in high school, you would have called it a system of two equations in two unknowns. So this x that is showing up here is supposed to be the same x that is showing here. Some unknown quantity showing up in two scenarios. Y, same way. So this x and y are unknown quantities, and now we have a system of two equations in two variables. Sometimes we call them unknowns. Okay, what do we want to do with them? Well, of course, the idea is to find which x and y actually fit this description. We are trying to find a number that makes both of these to be true statements. Okay, question? All sorts of things could happen, and we want to get ready for that. First of all, we are going to talk about how to find the solution. Back in high school, you have talked about elimination, substitution, or graphical solutions. We are going to review them quickly and also mention about some pathological situation or strange situation that could show up. So we want to talk about several things: how to find solutions, before we get there, we want to have just general idea of what kind of things to expect. Okay, sometimes you set out to go find something, but then it turns out that thing is not out there. Sometimes you try to find it and you say, well, just about anything you touch turns out to be a solution. Sometimes, or more often, you actually come by a particular solution that is kind of unique and such. Let's take a look at these things. Easiest way to understand the variety of scenarios is to get a visual impression, a visual description of the equations. Visual description of a system. Okay. I'm going to show you 3 scenarios and then ask you to investigate their solutions individually. One thing that we need here is to be able to draw the graph of an equation. So let me just briefly review this. Again, this is from Algebra 1, how to graph an equation. So this is going to be a quick review. I'm sure most of you are already familiar with it. Let's take one of these equations, say this one. Suppose I ask you graph x minus y is equal to minus 2. Now there are as many ways of graphing it as there are students sitting here. So just but everybody has a slightly different styles of doing it. Graphing is kind of like making omelet. You can do it a little bit this way, or you can do it a little bit that way. Eventually the omelet looks like any other omelet that you have made. Okay, tell me what do you do to graph this equation. Let's just get started. Suggest something. Such as? Yeah. Okay, somebody said figure out the x and y intercept, and somebody else said find out some points. So here are some ideas that come up. Start with intercepts. That's one legitimate way of. What do we mean? What do we mean by intercepts? Either x is 0, in which case y is what? If x is 0, you solve this equation, you get 2. Remember, that's really a solution of that equation. X equal to 0, y is going to be 2. What kind of intercept? What's the name of this intercept? This is called the y-intercept. So these intercepts are special solutions of our equation. How about the x-intercept? Who is 0 now? Y is 0. If y is 0, what is x? Negative 2. So okay, so this is 2 and 2. This is the point with coordinates minus 2 and 0. This is a point with coordinates 0 and 2. And then out comes, since we know the equation of this, the graph of this equation is going to be a line. That's why it's called a linear equation. And a line is specified by just having 2 points of it. We can say we are already done. Connect the 2 points and you are going to have your graph. Any other solution that you pick is going to show up on this black line. That's why we call this graph of this solution, meaning any point here has a coordinate. The pair of coordinates are solutions of this equation. Any solution of this equation translates into some point of this line. So there is a one-to-one correspondence between the points of this and the solutions of that one. So we say this is the graph of that. Similarly, we could go ahead and graph the other one. So I could go ahead and start with the other equation, 2x plus y equal to 8. Let me see if you can quickly tell me what are the intercepts of this one. What? So we have 4 zeros. We have, let's say, 1, 2, 3, 4. So x equal to 4, y equal to 0. And the other choice is what? X is 0 and y is 1, 2, 3, 4, 5, 6, 7, 8. I guess supposed to be all the way up there. Is that right? So we have this. So this is a graph of 2x plus y equal to 8, and this one is the graph of x minus y is equal to minus 2. Remember, we said every point of these lines, every point of this line is a solution of this equation. Every point of that line is a solution of this equation. If I want to find a simultaneous solution, that is an x and y that fits this as well as fitting that one, that particular point is going to be what point of this picture? The intersection. Whatever happens here, the intersection plays the role of the solution. So solving an equation translates into finding intersection of graphs of individual solutions. So, is that right? You want to solve that, it means you're trying to find intersection of two lines. Well, that's going to help us understand this next issue. The question is, what things could we expect? Now we are going to understand a variety of things that can happen. Here is an example. Suppose I had 2x plus y equal to 8 and 2x plus y equal to 4, and I ask you to solve this equation. Many of you probably can just look at that and come up with a verdict right off the bat. What would be the verdict? There are no solutions. Just looking at the equation, what is it about it that convinces us right off the bat that there is no solution? Yeah, this is same as that. And on the right hand side is 8 and right hand side of this one is 4. Well, that cannot happen. If it is 8, then why is it 4? If it is 4, why is it 8? So there is no x and y that solves this system of equation. We call the system inconsistent. Or we say it has no solution. In this case, it is obvious it doesn't have a solution. But sometimes that could be quite hidden. You have to work hard to figure out something doesn't have a solution. But if you have the picture in front of you, it cannot hide itself all that easily. Why? Because 2x plus y equal to 8, that is really y is equal to 8 minus 2x, is a line with y-intercept 8, slope minus 2. That's just the line we drew here. So that is, let me just quickly draw something. That's 2x plus y is equal to 8. Who's the other one? This other equation is y is equal to 4 minus 2x. That has a different y-intercept, but has exactly the same slope. So what happens about these two lines? They are parallel to each other. So these lines are parallel. And therefore there is no intersection. No intersection here means there are no x and y's that fit both of these descriptions. Unlike the situation here where there was one point sat on both of these lines. Okay, so this is scenario number 2. Scenario number 1 is that this is the most common situation you encounter. When you have an equation, they represent objects, the objects intersect at one point, and then you're all set. Here is a situation where they don't intersect. Your restrictions do not meet each other. Alternative number 3 is less common than this one, and would be something like this: 2x plus y equal to 8, and then 4x plus 2y is equal to 16. Again, looking at this equation, you can tell something right off the bat, which is second equation has a peculiar resemblance to the first one. What is it? Just double of the first one. So the second equation is not giving you any new information. There is no information supplied by the second equation. It's just somebody repackaged the first one and sold it to you as something new. So what is the mathematical effect of it? Mathematical effect of it is that if you go ahead and graph the first one, when you graph the first one, what do you see? Well, let's take this to be the red curve, 2x plus y equal to 8. Okay, there's going to be some line here, 2x plus y equal to 8. How about the second one? So 4x plus, if you try to graph it, what kind of a line are you going to get? It's exactly the same line. Okay, well, how many points do they intersect with each other? Infinitely many points. The two of them coincided on top of each other, and so every single one of these points is a solution. Every single one fits this and fits that one. In that case, we say we have infinitely many solutions. Which we can obtain by eliminating one of these ones, and from the first equation choose either x or y as your focus variable, calculate the second one, and create a solution set just like we were doing here. You remember what we were doing at the beginning of the hour? We were creating solution sets indicating we have infinitely many of them to deal with. So in this case we can do the same thing. We can create a solution set in the same style. So we did a very simple case, 2 equations, 2 unknown, but what we did is covering all possibilities. A linear system either has a unique solution that is the most common type. That's what we saw first. If you have a linear system like this one, either it cuts at one point, just like what we saw, or has no solutions, or has infinitely many solutions, or that's going to be a general theorem I'm going to prove or talk about it later on. It's very unlike equations you have seen in calculus. There are a lot more variety of things to happen there. Like an equation could have just exactly 3 solutions. You don't have any situation like that. Either you got 1 or none or infinitely many. We don't have a linear system that has just 2 solutions or 3 solutions or something like that. It goes between 0, 1, or infinity. No other choices. Okay. We have still a lot more to talk about. What we want to do is, let me ask you for next time, take a look at problems from (1 through 20). Yeah, solve as many of them as it takes. You do what is indicated here at the minimum among these problems, whatever is indicated here, that's the very first line of attack. Then if you have a problem with that, try to do extra. Questions you have, you can come to me. Pretty soon the tutoring is going to be available. It's not available yet. And I'll see you on Friday. The lecture is going to be posted to the website that you see at the bottom of this pink sheet.